Hello, everyone, and welcome to this session today. My name is Musa Peter, and I'm actually very excited to work with you through this introduction to Python programming. Python is one of the most powerful skills that you'll ever learn in this digital world. So join me today as I take you through this beginner-friendly guide to Python programming. So Python is majorly a programming language, just like the other different programming languages like JavaScript, R, we also have C++, and so many others. Python is a programming language. And what do we mean when we talk about programming languages? A programming language is a way that humans use to give instructions to computers. Remember, we cannot speak to computers directly via our mouth or even verbally. So you have to send instructions to these computers, and the computers must be able to understand the information that you are trying to pass through, or even that you're trying, the instructions that you are trying to give. So we use programming languages to send instructions to computers, and Python is one of them. Python is one of them, and it is majorly used in the world of data science, in development of websites, in automation, in artificial intelligence and machine learning. We use Python. And then apart from that, it is also used in scientific computing and also in the development of applications. So most of the applications that you use, like Jumia and very many others, different applications that you use on your computers and also on the mobile phones. Most of them have Python codes running on the background. So Python is majorly used in the development of applications and also in artificial intelligence. So why do we have to learn Python? Number one is that Python is very, very easy to read. Python codes look like just English sentences. So you can be able to read them and understand them. They are very, very easy to read. They are also simple, but very, very powerful. The knowledge of Python is used in development of applications. So we use simple codes, but very powerful ones. And most of the great companies like Google, Netflix, and also NASA, most of these companies use Python. They use Python to run their programs. So Python is very, very powerful. It is a powerful tool. Apart from that, Python has also a high versatility. It also has a high versatility. That means that it can be used in different ways. That is, you can use it in creation of websites. You can use it to analyze data. You can also use it to create different games, like video games and so many others. It is also beginner friendly. Any person who has never been into a Python class, they can learn Python quite fast. It is great fast programming language. It is a great fast programming language. So you don't need skills for you to learn Python. The only thing that you need is a mind that is open to learn. So it is always beginner friendly. And then apart from that, it has vast libraries. We have NumPy, Pandas, Matplotlib, TensorFlow, and Flask. So these libraries, they are majorly used for different ways. We can use them to maybe retrieve data, to maybe analyze data, and also to do some quantifications. So these libraries are very, very important. They are very, very important. And then Python also offers a strong community support. It offers a strong community support. And then apart from that, it is a high demand career skill. It is a high demand career skill. Like most of the companies will really look forward to working with people who have knowledge about Python, because Python, actually in the world of artificial intelligence, Python is as a high demand. So it is a high demand career skill. So since you now have a basic understanding of what Python is and how and why we should learn it and to how to navigate about it, in case you need more information about introduction to Python, go back to the first video that I did, and you'll be able to get more information about that. So let us proceed on how to install Python. How do you install Python? So you navigate to the official website, the official Python website, that is python.org, and you'll be able to download Python from their website. And then after downloading it, you install it. And after installation, your Python is ready for use. It is ready for use. Then writing your first Python program, your first Python code. Every person is always super happy to have or even to write their first Python program. Now, for this session, we are going to be using Jupyter notebooks. We are going to be running our codes within Jupyter notebooks. So in case you are not well conversant with Jupyter notebooks, you can also proceed to the first, you can also check on the first video that I did, and you'll find out, you'll get some more information about it. So you can also use Google Colab, you can also use Visual Studio Code and very many others to run your codes, very many other applications to run your codes. But for this specific session, we are going to be using Jupyter notebooks. So within Jupyter notebooks, this is how it looks like. This is an example of a notebook. So it contains blocks, different blocks, and each block is called a cell. Each block is called a cell. Like this one is a cell, this is a cell. We have three different types of cells. We have a code cell. A code cell stores codes, or even it is where you put a code, and whenever you run a code, you always get an output. And then we have a markdown cell. A markdown cell is a cell that is majorly used to house explanations. For example, if you wanted to explain something, you put that in a markdown cell. Like this one is a markdown cell. So you can do whatever you want to do. You can maybe use different font styles. You can use different sizes of letters, that is font sizes, and so many others within a markdown cell. That is what happens. And then the last type of cell is called a row cell. In this case, a row cell is used to house, it can house either comments or maybe a code. But in this case, whenever you run it, you don't get feedback, or even you don't get an output in that case. So if you want to get an output within Python, then you use this specific keyword, print. You use print. So the moment you type print, then what happens is that you are telling Python to output the information that comes after the word print. So in this case, we have print hello Python. That is the information. We've enclosed that within double quotation marks because this is a string. It is a string, or even it contains characters. It is a string in this case. So anytime you are using strings, you enclose them within, or even if you want your output to be a string, then you enclose that within these double quotation marks. So once we run this, then our output is going to be hello Python. It's going to be hello Python. So how do we run cells? How do we run cells? I mean, how do we run codes within cells? You navigate to the top bar in this case, and you'll be able to see this triangular icon here. And then once you click on that, it's going to run that cell. Or you can use the different shortcuts, keyboard shortcuts. You can click on Shift Enter. So if you click on Shift Enter, then what happens is that you run that, Python will run that cell successfully. And this is our output, hello Python. Hello Python. And there you are. You've already done your first Python program, or even you've already written your first Python code. Hello Python. So we've printed out that. You can change this to anything. We can change that to hello Musa, then welcome to your first Python class. Welcome to your first Python class. Something like that, and then we run it. So after we run that, you're going to see the output here. So what happens is that Python basically prints out what you have within the brackets. So you enclose what you want it printed within this parentheses. So this session is all about data structures. That was just a brief introduction. It is all about data structures. So we need to know what are data structures. And data structures, they are ways that are used to organize and store data in a computer's memory. So data structures, they are ways that are used to organize and store data in a computer's memory. Just the same way that you organize clothes in a closet. Whenever you're done maybe laundering your clothes, and after maybe you're done folding them, you organize them in your closet, or maybe you can also hang them somewhere. So in this case, Python is a programming language, and you have to ensure that the information that you store within your computer is retrievable. So you have to, the data that you are using must be organized and also stored in a retrievable manner. So we use data structures to organize and store this data. And we have different types of data structures. So the best term to describe to these data structures is just like a container. So a data structure is just like a container. So what you do is that if you wanted to maybe store yogurt, you have your yogurt in a container and then you seal it. So that becomes now like a store for your yogurt. So in this case, data structures occur in different types. So we have the first data structure, which is called a list. A list. So we have lists, and we are going to discuss about that. So a list represents items in an order. You can think of that as a shopping list. Anytime you are going shopping, you always have a shopping list. And in that case, you always organize your items in an ordered manner, whereby you arrange them in their priorities. The one that is basic appears on top, and the one that is maybe not basic will appear at the bottom. So a list is a data structure. Then we also have a dictionary. In this case, a dictionary contains words with their definitions in this case, and we are going to expound on that. And then we also have a set. That is the third data structure, a set. A set. An example of a set is like just a bag of unique items. A bag that contains unique items. Items that are unique. None resembles the other. It contains unique items. No duplicates are allowed. A list can have duplicates, but a set cannot have duplicates in that case. And then the other one is a tuple. A tuple. So a tuple is like a sealed envelope. You can think of it as a sealed envelope. Yes, you can see the envelope, but you can't see what is inside the envelope. So once you create a tuple, you can't change it. You can't change it. It's already sealed. You can think of it as an envelope that contains money. So once you put money in an envelope, you can't unseal it unless it is delivered to the person who was supposed to receive it. That is the recipient. So a tuple is like a sealed envelope. And just like I said, we are going to discuss that further as we progress. So before we navigate to the different types of data structures, it is good for us to understand the basic arithmetic operations that we'll be using, or even that we'll be working hand in hand with these different data structures, because we are going to be doing some manipulations, or even maybe we are going to be using the data structures together with these arithmetic operations, or even the arithmetic operators. So we have what we call arithmetic operations, and these are actually the building blocks that you'll be using everywhere in Python. Majorly, you'll be using most of these arithmetic operations. These are operators that enable us to be able to manipulate or even to work around our data structures in this case. So we have different basic operators. We have addition, subtraction, multiplication, division, and there are signs. Subtraction, this is a sign for subtraction. That is a sign for subtraction. Then division, we use a slash. And then we have floor division. Floor division. Floor division means this division that rounds down. So you divide and then finally you round down your answer to a specific number of decimal places in this case. And then we have modulus. This outputs the remainder after division. What remains after dividing two numbers? Assume that you are dividing 3 and 4. 3 divided by 4, or even 4 divided by 3. You know that 4 divided by 3 is equals to 1, remainder 1. So if you use modulus, then you expect the output to contain the remainder, what remains after division. And then the last one is exponentiation, or even the power. This one, that is the last basic operator. And I just want us to work around these different operators and see how they are going to behave. So in this case, we are going to define our variables. So we have our variable. A variable is a value that, it is actually a value that might change. It is not static. It can change over time. So the value of A is 10. Tomorrow, the value of A might be 20. The next day after tomorrow, the value of A might change to maybe 50. So A is a variable. So we call this a variable. So in this case, we are defining our variables. We define our variables. We are defining our variables. So the variables, they are now the the values, or I mean, they are now it's like the name tags, tags that were given to all these. So A is equals to 10 and B is equals to 3. So we store the number 10 in a variable called A. It's like a bucket. So 10 will be contained within A. So the bucket that contains A, the number 10 is A. And then the bucket that contains the number 3, sorry, it's B. So these are now the variables that we are talking about. So if I wanted to maybe sum these two numbers, 10 plus 3, then I would definitely just write A plus 3. So I will use a basic operator within, that is between them. And then I can now print out the final answer. So print, these are strings. So I want my final output to contain this. Addition of 10 plus 3, or even addition of 10 and 3 should be the output of this, A plus 3. So A plus 3 is equals to what? So we run that. And after running that, you can see that the sum of 10 and 3 is 13. Now, it is not a must for you to write all this. You can omit that and just write print. Just write print. Print. And then what are we printing? We are printing A plus B. So A plus B. And then run that. So the moment you just write print A plus B, you're going to get this. This is the output. This is the output, 13. And then this is just an additional information. You can add it. That's just an additional information. So the same happens. Whenever we subtract them, A minus B, we get 7. A minus B gives us 7, so it is 10 minus B. If we multiply A and B, what we get is 30. A times B gives us 30. So why is this working? Because we already defined our variables. Remember, we already defined our variables. And then A divided by B gives us 3.333. That is 10 divided by 3, you get all this. You can round down your answer to maybe a specific number of decimal places. So if you want to round down your answer such that it is not going to have all these decimal places, then you use floor. You use floor division. So if you use floor division, then you are going to get only 3. It's going to give you 3. So when you have 3 rounded down to 0 decimal places, then what you are going to get is only 3 in that case. And then if modulus gives us the remainder. What remains after 10 is divided by 3? What remains? Now 10 divided by 3 gives you 3 and then remainder 1. So the remainder in this case is 1. The remainder in that case is 1. And then the last one is exponential. Exponential means a number raised to another number, or even a number multiplied by itself a multiple number of times, or even a specific number of times. For example, R raised to the power of B. This means you pick A, multiply with itself B number of times. So for example, if we have A was 10 and B is 3, that means you pick 10 multiplied by 10. That would mean to be 10 multiplied by 10 multiplied by 10. That is 10 multiplied by itself 3 times. And what you get, you're going to get 1,000. So if you pick this, it's going to give you 1,000. So instead of writing this, because sometimes you might have a number raised to maybe 1,000,000 times. So that won't be able, you won't be able to type this number 1,000,000 times. So what you do is that you use exponential. This one raised to the power, to a specific power. So for example, if I have something like 10 raised to power maybe 4, or even maybe let me use 6, you're going to see the output is going to be, in this case, the output is 1,000,000. So 10 raised to power 6 is 1,000,000. It is 1,000,000. Okay. That is what we have. So those are basic operators. The second type of operators that we are also going to be using, they are compound assignment operators. Compound assignment operators. And operators, these are shortcuts for updating variables. So instead of writing x is equals to x plus 5, you can just write this. Instead of writing x is equals to x plus 5, you can write x plus is equals to 5. So what will happen is that you are telling Python to pick the value of x, then add 5 to it. That is what you are telling Python to do. Let me give an example in this case. So if our variable x is equals to 5, then let us first of all print that. We print out the starting value. So our starting value for x was 5. It was 5. That is what we had. So in this case, if we want to add 3, then we can do it in two ways. Now let me add a cell here. Let me add a cell here. And let me just copy this. Copy. For example, if I have x plus 5, let us see what we get. So x plus 5 is equals to 10. So what Python does is that it picks the initial value of x, which was 5, then plus 5, which gives us 10. So instead of writing x plus 5, you can just basically pick x, and then plus is equals to the value that you want it added. So plus is equals to this. It is the same as you're telling Python to output the value of x after adding 3. What is the value of x after adding 3? So in that case, let us run that and see. So the value of x after adding 3 is equals to 8. Is equals to 8. And then if you wanted maybe multiply the value of x by 2, the output x would be what? So you type x, then multiplied by equal to 2. So this tells Python to output the value of x, in this case, after multiplying that value with 2, or even after multiplying the initial value of x with 2. So after running that, you get x is equals to 16. X is equals to 16. X is equals to 16. So why are we getting 16? Remember, we had already added x to 3. And what we get, our new value of x is not 5, but 8. So our new value for x is 8. So we are adding something to x. So if we run the fourth cell, then our new value for x would be 16. So it will be 16, and then in that case, we divide by 4, and then float the answer. We float the answer. So after floor dividing by 4, we get 4. So 16 divided by 4 gives us 4. And that is it. So these are compound assignment operators. They are compound assignment operators. Compound assignment operators. So these ones, they are used to, you use them when you want to assign a specific value to a specific variable. Or even you can also use them whenever you want to update a variable. What you do is that you use a compound assignment operators in that case. So that was the first one. Operators. We discussed about different types of operators. That is arithmetic operators and also compound assignment operators. So I want us to now dig deep into lists. I want us to discuss about lists. This is your first data structure. So what is a list? So I said a list is an ordered collection of items. It is an ordered collection of items. A list is an ordered collection of items. So you can think of this as a shopping list, whereby you have your most important items appearing on top, and the least important appearing on the bottom. So they are usually ordered. So you can think of it as like a shopping list or even a to-do list. So items are not in a specific order. The items in this case are not in a specific order. And you can add, remove, or change the items, just like a shopping list. You can decide that you will have something on maybe if you are buying shoes, you're buying clothes, you're also buying food. You can decide to start with shoes and then end with food in that case. So they are usually ordered. We order them, but they do not follow a specific order. The arrangement is you to come up with the arrangement. So what are the characteristics of lists? Number one, the items stay in the order you put them. So they are ordered. So they usually stay in the order you put them, not until you make any changes. Number two, they are mutable. Mutable means, or even mutability of a list means that you can change the items after creating the list. You can add an item to that list. You can remove an item from the list, or even you can also modify an item from the list. You can also modify a list in that case. So lists are mutable. They are usually mutable. They also allow for duplication. They allow for duplication. You can have duplicates within your list. And then you can use mixed types. Remember, we have different types of data. We have numbers, we have text. In this case, text represents string. We also have numbers, which are now digits. We also have floats. Floats are actually numbers with decimal points, and a lot more. So they allow you can be able to use different data types of data, like numbers, strings, and also floats. And then the last one, the last characteristic of a list is that they are usually indexed. Each item has a position number. Each item has a position number starting from 0. Now, Python has what we call negative indexing in this case. So the first item of the list will be counted as 1, or even it will have, it will be counted as 0, sorry. It will be given index 0. So I will discuss about indexing as we progress. I'll discuss about indexing. So this is a general syntax. So you'll have my list is equals to item 1, item 2, item 3. So if you have item 1, in that case, then this is your item 1. That is your item 1. This is your item 1. So item 1 is always given index 0. Then item 2, it's index 1, and item 3 is index 2. So if you have 3 items, you'll be having indexes until 2. In that case. You'll have indexes until 2. Okay. So this is what I have said. So this is index 0. This is index 1, and this is index 2 for the items that you have. Okay. So lists use square brackets. That is the other main point. All lists use a square bracket. So there are different types of brackets that are used within different data structures. So for lists, you'll only be working with brackets, square brackets. So they use a square bracket. So anytime you use a square bracket, Python recognizes that as a list. And it will be able to, because it knows all the characteristics of this list. So it allows you to perform any of these within that specific list. So you can maybe you can change, you can modify the list, you can also maybe duplicate, or you can also change the type. You can also maybe add some values within the list. So how do we create different types of lists? For example, in this case, assume that we want to create a list that contains the different types of fruits. So what you do is that you just type the bucket, or even the basket that will contain your values. So in this case, my variable is fruits. That is my list name, fruits. So fruits include apple, banana, cherry, and even dates. So these are strings. The data type in this case, they are strings. So since they are strings, you have to use either single or double quotations for each one of them. And then you separate the values using a comma. And then do not forget to use double square bracket. Do not forget to use square brackets in this case. So this is my variable name, or even the basket that contains my values, or even the values. And then we've enclosed them within square brackets, and we've separated them using a comma. And then if we want to print out our list, then we just type print and then the name of the list. In that case, just like I said, this is additional information. You can omit it. You can omit this. It's just additional information. So we are printing out the fruit list, and our fruit list is apple, banana, cherry, and even dates. That is now the fruit list. We can also have a list of numbers. So if they are digits in this case, then you don't enclose them within double quotation marks or even single quotation marks like these ones. So you just write them. So whenever you enclose these, the numbers within quotation marks, then Python recognizes that as a string, but not a number or even a digit. So my numbers is 1, 2, 3, 4, 5. So we are printing out the numbers list in that case, and you can see what we have. So this is our list. This is our list. Now, assume I have something like this, numbers. I just write numbers and run that. So the moment I run these numbers, Python will also recognize that I'm calling out my list in that case, and there will be an output. So you can write print numbers, or you can just write numbers in that case, or the name of the list, and Python will recognize that as a list in that case, and it will output the answer. Then we have a mixture. Assume that you have a list that contains digits, and at the same time, it also contains characters, that is text. It contains text, and even floats in that case. So what you should do in this case is that you have to create a variable name, which is now the mixed. We can call it the mixed list. So in this case, it contains these are digits. We also have a string, we have floats, and yeah. So we have all these types of data types enclosed within square brackets, and then we call it out, or even we print it out. And after calling it out, what you are going to have is this. So the mixed list contains contains hello, 3.14, and true. That is it. And then you can also have an empty list. We can add items later. You can create an empty list in this case, and then maybe add items later. You can add items later. So empty list in this case is going to be, you're just going to write square brackets and then leave it blank like that. And then you can print it out. And after printing it out, you're going to see that it's also going to return an empty list. So later on, we are going to discuss about how to add items onto a list. Assume that you had an empty list. How do you add items onto that list so that it doesn't remain empty? So I'm going to show you about that, or even I'm going to discuss about that. Now, just like I said, we usually have what we call indexing. Indexing represents the index occupied by each value within a list. So the first value will always be given index 0. The second one will be given index 1. The third one will be given index 2. And the fourth one will be given index 3. So this is an example of what happens. So within our fruits list, apple is index 0, banana is index 1, cherry is index 2, and dates are index 3. So you can also have what we call negative indexing to count from the end. So negative indexing counts from the end. So if I use -4 will, Python will start counting from here. So this will be 1, 2, 3, 4. So apple would be the output in that case. We are counting in the backward direction, 4 steps. Then -1, in this case, it will be the last value here. -1, -2, -3, -4. So this is -1. So if I was to use -1, or even if I was looking for the value within my list that is negative as an index of -1, in that case, then the output will be dates. It would be dates. Okay. So let me run this. So I have my fruits list, and I want the value that is within the first, or even I want the first value in that case. So that is index 0. That is index 0. So what you do is that you type the name of the list and then the index enclosed within square brackets, because we are working with lists. And then we run that. So if you run that, you're going to see the output is apple. You can also do the same for the first one, the first index, and the first index is banana. That is the one occupying the second position. The third value, which is now index 2, will be cherry. And then if you want the last fruit, you can use negative indexing. So that will be -1, or you can also use 3. If you're using positive indexing, that would be 3. Okay. So if we run that, then we are going to get the answer as dates. Now, if you want the second to last, the second last one, then we use -2 as our index, -2. And the answer would be cherry. So that is what happens with indexing? So we've said that Python starts counting items from 0, counts them from 0, and it gives indexes from 0. The second characteristic of a list is now list slicing. List slicing. Now, slicing lets you get a portion of a list. It allows you to get a portion of a list. So assume in this case, I have this specific list and I want to get the first 2 items. I will have to slice them from my list, or even from my fruits list in that case. So slicing is all about using or even getting a portion of your list. So what happens is that the end index is always not included. That is what you should know. The end index is always not included. Why is it not included? Because in this case, if I want the first 3 values, in this case, it will be 1, 2, 3. So I want the values from index 0 to index 2. But what you do is that you will call out the values from 0 to 3. So the last index will not be included. That is what happens with Python. So the last index is always not included. Is always not included. So if you run this, your list, and then now the start index, and then the end index, in this case, this will generate all the items from the start to the end minus 1. And then if you use something like this, list, you call out items in your list from the start, and then you use colons, and then nothing after colon, then that will call out all the items within your list. All the items within your list. And then if you use something like this, you give the name of the list, and then space or even nothing before the colon, and then the end index in this case. This will give the items from the beginning to the end. The beginning to the end minus 1. So this is actually the same as the first one. It is actually the same as this. It is actually the same as that. Okay. And then you can also use a list, and then you give the start index, the end index, and then the step. So this will give the items from the start to the end minus 1, skipping the number of steps. So if you use 2 as the step, then it will skip 2. If you use maybe 3 as the step, then it will be skipping 3. Now, let me give you examples using this. We have this list called numbers, and we have all these numbers. So let us slice them. We assume we want to get the first 5 numbers, So the first 5 numbers are the numbers occupying index 0, 1, 2, 3, and 4. They are occupying index 1, 2, 3, 0, 1, 2, 3, 4, those ones. So within our slice, we are going to use 0 to 5. But remember, the last index is always not included. So this one will generate this as the output. So the output would be 0, 1, 2, 3, 4. And then if I want all the items from 3 to 7, from index 3 to 7, in this case, what I will do is that I will call out my list, and then I will use the indexes, index 3 to 7. So this will give me this value 3, 4, 5, 6. So the last one, which is now 7, will not be included. Okay, so let me run that. So if I run this, you can see the output of the first one and the output of the second one. So this gives the values from index 3 to index 7. Now, there is a difference between the first expression and the second one. In the first one, we were looking for numbers from 0 to 5, from index 0 to 5, and it gave us the first 5 values. And then the second one, we used index. So we are looking for numbers from index 3 to 7. From index 3 to 7, so that would be numbers, and then we input the indexes, their indexes, from 3 to 7. So the last index would not be regarded, or even it would not be included. This always not included. Then we have this. So assume we want the first 5. So if we want the first 5, that would be the numbers from index 0 to index 5. From index 0 to index 5 in that case. Okay, let me just take you to this. So we have all these indexes. So just like I said, we have index 0 all the way to index 3. Index 3. So if I want the first three values, then that would return the numbers within from index 0 to index 2. That is what I said. So the last one is always not regarded. The last value is always not regarded. So I want the first 5. So I will use a space here. I mean that is now from the beginning to index 5, and that will return the first 5 values. And then the last 5, I would use -5. In this case, -5 as the start, because I want the last 5, -5, until the end. So the colon then space means until the end. And then if I want everything, I'll just use space, colon, space. I'll use space, colon, space. And that will return everything. To return everything. Okay. Then the next thing is slicing with steps. Slicing with the steps. So assume we want to jump every 2. We want to jump every 2 numbers, or even we want to have steps of 2. Steps of 2. So our numbers, they were 0, 1, 2, 3, 4, 5, 6, 7 until 9. So we want to now jump. We want to make 2 jumps in this case. So if we are to make 2 jumps, then you'll be having this. You'll be having something like this. Let me just show you that. You'll be having something like this. So this is the first, and then the second. So you will have index 0, then, I mean the first value, then make 2 jumps, then this value here, and then you'll make another jump, 1, 2, then you'll pick 4, and then make another jump, 1, 2, then pick 6, then 1, another one, 1, 2, then pick 8. So in that case, you are making jumps of, you are making 2 steps. You're making 2 steps from each number. So once you run this, once you run that, what you are going to be getting is these values here, 0, 2, 4, 6, 8. If you make 3 jumps, then you are now going to be having 0, 3, 6, 9. So it's going to be making 3 jumps instead of 2. And then you can also have reversed jumps in that case, reversed jumps. So you are now making the jumps, but in reverse order. -1. -1 tells you that you are making the jumps from the last value, which is now 8, which is now 9, sorry, which is 9. So you'll be making jump one step from each number. And what you get is the entire list again, but now in the opposite manner. So you'll begin with 9, 8, 7, 6. You can now see the values. So that is what we call slicing. That is what we call slicing. So with slicing, you can be able to extract a portion of your list. Remember, we said that lists are actually mutable. They are usually mutable. You can change values within a list in that case. Now, let us proceed to mutability of the list. In this case, lists are mutable. That means that you can change them after even creation. So we can change individual items within a list. We can also add new items. We can also remove items, and we can also rearrange items within a list. We can rearrange items. Now, assume we have this specific list, which contains 3 fruits. So let us print it out and see what we have. So our original list contains these three fruits: apple, bananas, and cherry. So if we want to modify the item in index 1, we want to modify the item in index 1. In that case, we want to change it from banana to blueberry. We want to change banana to blueberry. Then what we do is that we write the name of the list. The name of the list was fruits, and then followed by the index that we are willing to change, and then is equals to. Is equals to means, in this case, we are now regarding that value as another value. We are now changing the initial value to another one. So fruits, and then the index 1 is equals to blueberry. Let me also make a few modifications. Let me make another modification. Let me also change maybe fruits and then index 1 to something else. Let me change in index 0. That is the first value to maybe also blueberry. So let me print the values after changing index 1 and also 0. That is index 1 and 0. Let me print the fruits. So you can see after changing index 1 and 0, our list contains blueberry, and cherry. It was apple, banana, and cherry. But now we are having blueberry, and cherry. Just like we said, list can have duplicates. So in this case, you are seeing duplicates. We've changed the values, but now it allows us to work with duplicates in that case. So we have different methods that we can use to make these modifications or even to work around with our lists. We can use append. Append is used to add items to the end of a list. We have insert. Insert is used to add items at specific positions. We have remove. Remove is used to remove the first occurrence of the item. So you can remove the first occurrence of that item. For example, I can remove blueberry in that case. We also have pop. Pop removes and returns the last item. So it removes and returns the last item. So I'm going to explain about that. Then we have pop and then followed by the index. This one removes and returns items at a specific index. So it will remove a specific item and then to return an item at a specific index. Then we have sort. Sort is used to sort the list. Then reverse function reverses the list, like what we did above. If you had a list 1, 2, 3, 4, 5, you reverse it such that it begins with 5. Then we have count. Count is used to count the occurrences of items within a list. And then index is used to find the index of the first occurrence. So these are several examples, and we are still going to be working with our fruits. So let me run that. So the first thing we define our list is it contains apple, bananas, and cherry. So assume we want to add the word dates. We want to add this date to this specific list. So what is going to happen is that it's going to be added at the far end in this case. So you write fruits.append and then the name. You need to check on the brackets. For this, for the list, we had used square brackets. But for this one, we use parentheses. We use parentheses because we are adding a specific string in that case. So fruits append and then the name of the fruits. And then we print the fruits after appending or even after adding. And you can now see that we have apple, banana, cherry, and dates. And then we can also insert avocado. We can now insert this specific fruit at index 1. We can insert avocado at index 1. So we write fruits.insert. Then the index, where are we inserting it? We are inserting it at index 1. And then what is the name of the fruit? Avocado. So if we are to type that, if we were to run that, we would have avocado between apple and banana. What we had here was apple, banana. But now in between apple and banana, we have the word avocado because that is index 1. Then we can remove specific items. For example, in this case, assume we want to remove cherry from that specific list. So you just type fruits.remove and then the name of the fruit that we want to remove. Now remember, Python is case sensitive. So if you had used maybe capital letters or even uppercase for the cherry, and here you use lowercase, you're going to receive an error. So you have to ensure that the cases are the same. So we use fruits.remove, then the name of the fruits, and then we run that. So after running, or even after printing out fruits, you can now see that our new list does not contain the fruit cherry, doesn't have the fruit cherry. And then assume we want to remove and return the last item. We want to remove and return the last item. We use the word pop. So we are going to create a new list, which is called popped item. And popped item is equals to fruits.pop. Fruits.pop. So what this does is that it will remove and return the last item in that case. Now, let me give an example. If we print out the popped item, in this case, you notice that it has cleared every other fruit from our previous list. It has cleared out every other value from our previous list in this case, and it only returns the last item. So what happens is that pop will only return the last item in that list. So assume you have a very, very large data. You have values from 0 all the way to maybe trillions, and you want to get the last item on that list. You use the word pop. You use the word pop. So if you use pop, it will generate the last item of the list. It will give us the last item of the list. And then, so now we've printed out the popped item, which was the popped item. So the popped item is now the last item, which was deleted. So now if we print out our list, our initial list, in this case, it is not going to show that item. It's not going to show that item. So what it does is that it identifies the last item, it identifies the last item, it identifies the last item, which is this. It identifies the last item, which was this. And after identifying the last item, which was dates, it now deletes it. It now proceeds to deleting that item. So after deleting the item, you can now see that our list after the pop does not contain dates, does not contain dates. Okay. Then let us work with numbers. Let us work with numbers. We've now been working with strings. Let us work with numbers. So assume you have this list that contains numbers. In this case, let me just run it so that it is identifiable within Python. So that is our list. So assume we want to sort these numbers in ascending order. We want to sort them. So what you do is that you use the sort. So numbers.sort, and then you enclose that within brackets. There is something that you are realizing. Whenever we use pop, in this case, and also sort, we do not input the name of the list within the parentheses. We do not input, we just put brackets in that case. So sort sorts the values in ascending order. In this case, whenever you use sort, it will sort those values in ascending order. So as you can see, we are having these values sorted in ascending order. The values are now sorted in ascending order. They are sorted in ascending order. Now, if you want to sort them in descending order, then you add something else. Within the parentheses, you add the opposite, you add this statement, reverse is equals to true. Reverse means that the first one was ascending order. So if you write the reverse of ascending order is descending order. So reverse means opposite. So the reverse, which is now ascending order, is true. That means that is what we are interested in. So you are telling Python, reverse your sort. Because after sorting, the values are now going to be grouped in ascending order. So you are telling Python to reverse this order, such that if what you had was 1, 1 will now be appearing at the far end. So you will change the order. And after running that, you will have your values as 9, 8, 5, 3, 2, 1. So we've reversed that to descending order. We've reversed that to descending order. And then you can also use reverse. You can also use reverse. So if you write numbers.reverse, this one will reverse the order, to reverse the order. So instead of using sort, this one is a bit long. Instead of using the word sort, if maybe your values are already sorted, then you can use reverse. And if you use reverse, then you'll get the values, the order reversed from 9, 8, 5, 3, 2, 1 to this. Now, let me give you another example. Let me give you another example. So assume we had something like this. Num. Let me talk of maybe cards. Cards is equals to maybe 1, 2, 3, 4, 5. That is now, those are now cards. And this is the list. So we have to put that in square brackets. Cards is equals to that. And then we reverse that. Copy this. Cards, reverse. Now let me use different values. 10, 50, and then 80. So I've used different values that are mixed up, and let us reverse that and see what you're going to have. And then I've not printed out. So print cuts. So you can see that if you use the word reverse, then what you are having here is that it just reverses the order. Python will just reverse the order, but will not sort the values. The values have not been sorted. It just reverse them. We had 10 appearing as the first, or even as the first number, but now it has been reversed. The order has been reversed. So it is now the last value, but it has not been sorted. So you have to sort your values before using the reverse function in this case, or even before using the reverse keyword. You have to ensure that you sort them first. And that is it. That is it. So we have now the last part, which is list comprehensions. These are powerful shortcuts. So list comprehensions, they allow us to create new lists in one line of a code, and it's a more elegant way to create lists. It is a more elegant way to create lists. And this is actually the syntax, the expression for the item in iterable if condition. So we have what we call a for loop. And in this specific notebook, we are majorly going to be interacting with for loops. So assume you have this empty list, which is called squares long. That is an empty list, just like I said. So squares long. So what we do is that we want to create a list of squares the long way. We want to create a list of squares the long way, using the long way. So we first begin by creating an empty list that is supposed to contain different squares, that is the squares of numbers. Whenever you square 1, you get 1. Whenever you square 2, you get 4. Whenever you square 3, you get 9. So we want to come up with squares. So we are going to use a for loop. So for x in range of 1 to 6, append these values, the value of x raised to power 2, or even the value of x here raised to power 2. So what is happening here is that we are picking every value. Remember, our range is from 1 to 6. We want our values from 1 to 6. So for every value, in this case within this range, pick that value, raise it to power 2. And then after getting the values, or even after getting the outputs, append them. Appending, we've said that appending is used to add an item to a list. So we add those items to this empty list, and then we print out the list and see what we are going to have. So if you run that, you can see that we are having 1. We are having 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Remember, I said that the last, in this case, this is the range of 1 to 6. So the last index will not be considered. So you will have 1, 2, 3, 4, 5. Those will be the values, the values that will now be squared to give us the list. So this is what we've done. So we've added in values to an empty list. Now we can also create the same list with a list comprehension. A list comprehension is always shorter, just like I said. So this is a long way of creating lists. And we've used what we call a for loop. A for loop. We've used a for loop. Let me write it somewhere. So what we've just used is a for loop. It's called a for loop. A for loop. And a for loop is used, we shall majorly be using it. I will discuss about it as we progress. So that is it. That is it. So now we can use a shorter method to work out that. So what we are going to do is that we are going to come up with another list called the squares short. And then what we do is that we enclose that within the square brackets. So instead of writing all this specific code, we just pick this value, x raised to power 2, for x in the range of 1 to 6. So we've replaced this. So for x in range of 1 to 6, so for all the values running from 1 to 6, that is from index 1, I mean from number 1 to 6, remember the last one is not included in this case, pick that value and raise it to power 2, and then print out the name of the list. Print out the list and its values. And what you get is the same output. What we get is the same output. So these are a bit shorter. These are the first one was a bit long. The first one was a bit long. And then the last one, assume we want a list comprehension with conditions. And in this case, assume we only want a list of even numbers, So we are going to use something like this. So for x in range 1 to 11, if x modulus 2, x modulus 2 means x divided by 2 is equals to 2. So in this case, we are actually interested in the numbers that whenever you divide them by 2, you do not get a remainder. So x modulus 2 is strictly 0. That means that there is no remainder. So if any values or even any numbers between 1 and 11, remember 11 is not included, it is the last value. So any numbers between 1 and 11, in that case, not between, but from 1 to 11, if we are having those values divided by 2, if the output is 0, that is the modulus is 0, then return that as one of the values within this list. So if we print out that, you can see what we get. So the first value is 2, because 1 divided by 2 it's actually a fraction. So the first value is 2 and the last value is 10. So these are the numbers that do not have a modulus. That means that whenever you divide them with 2, you do not get a remainder. So this is it. Now there is also a longer way. We can also use a longer way, maybe just like the first one. So what I'm going to do, I'm just going to copy this and maybe make a few changes. So I'm going to have even. I'm going to change that to even long is an empty list. So for x in the range of 1 to 11, we change that to 11. Then I change this to squares. Change that to even, sorry. So even long dot append this. So we are going to append. What are we appending in this case? We are appending the values. We are appending the values. We are appending the values. These values. So we append the values if x modulus 2 is equals to 0. And let us run that. We are having an invalid, okay, I think we have an error somewhere. Okay, it's okay. So what I said is that is a longer method. It's actually a longer method. So a better one is we use what we call the list comprehensions. In that case, it is a better one. It is a better one to work around with. So that marks the end of our session for today. So the next one, we are going to be discussing about tuples. So feel free to interact with this. And I'm going to also append this notebook on the description so that you can also maybe download it and use it for your, maybe for your coding. You can use it for your coding. Goodbye.